वेल सो भाइयों और बहनों, आज गुरुजी ऑनलाइन आपके लिए रियल टाइम क्वेश्चंस लेके आए हैं. टुडे वी आर गोइंग टू सॉल्व द प्रॉब्लम्स which have really appeared in the AIEEE exam in various years. I have collected these questions pertaining to the chapter nuclear physics. So we will see one by one and we will solve the real time problems. And this is definitely going to give us some kind of confidence in cracking the questions in the exam. So first question is, if N0 is the original mass of the substance of half-life period 5 years, then the amount of substance left after 15 years is, so these are 4 choices. This question appeared in 2002. So here we are given half-life period and we have been asked the substance left after 15 years. So our normal equation is like this. Here T is equal to 15 years. T by 2, T1 by 2, that is half-life, it is given. Lambda, we know ln 2 upon T1 by 2. So from here we can find out lambda. T is given. So N0 is N0 and we have to find out what the substance will be left after 15 years. If we put all these things, then N will be equal to N0 E minus ln 2 divided by 5 into 15, or N0 E minus ln 2 into 3, or we can write this as E minus ln 2 raised to 3, or we can write it as N0 divided by E. Now it will become plus, and this is 2 raised to 3, and this will be nothing but N0 divided by 8. So our answer is this. Instead of doing all this process, we can find out in simpler terms also. Here it is half-life is T1 by 2 is 5 years, and T we have to find out, that is 15 years, and it is 3 times. Okay, so 1 by 2 into 1 by 2 into 1 by 2 3 times, if you take, that will be nothing but 1 by 8, means the substance will originally it will become N0 by 8. So you can solve this problem within 15 to 10 seconds. Now we will go to the next problem. This problem appeared in 2003 AIEEE It says when U238 nucleus originally at rest decays by emitting alpha particle having a speed u, the required speed of original nucleus is. So what we have been given is, this is a nucleus of U238. Okay. Now it is emitting an alpha particle with a speed u. So when it will emit an alpha particle, it will result in some substance X 234 plus He42. Now this, when alpha particle is emitted, what remains is this, and this will recoil. This X will recoil. Suppose it recoils with a speed of v, then with the conservation of momentum, so we can, this is mass of this is 234, v is equal to mass of this is 4, u, v is the thing, but 4u upon 234. This is the answer. So now we will go to next question. A nucleus which is having Z is equal to 92 emits the following in sequence: alpha, alpha, beta minus, beta minus, alpha, 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 beta minus, alpha, beta plus alpha. The resulting nucleus is this. So first of all we will see alpha. How many alpha particles are coming out? 1, 2, 3, 4, 5, 6, 7, and then 8. How many beta minus? 1, 2, 3, 4, 4. And how many beta plus? That is, now what is remaining is beta 1, 1 and 2. That is 2. Okay. It has, alpha particle has atomic number as 4. Beta decay. In beta decay what happens? Let us see what happens in beta decay. Beta minus decay. Actually, in this beta minus decay, a proton is a neutron. Basically, a neutron is converted into a proton then one electron, then one anti neutrino. Now in this beta decay, this proton is, one neutron is becoming less, but one proton it is producing. That means it will have +1. Contribution in the nucleus. And in beta plus decay, what happens? A proton is converted into a neutron plus one positron and neutrino. This is called positron. So, since one proton is converting into neutron, that means +1, it is becoming less. That means it is converting -1. So, let us see 8 into 4 plus 4 into 1 minus 2. This is the contribution. 8, 12 plus 4 minus 2 means this will become 14. Now, Z was your 92 minus 14, it will become 78. So, what is the answer? The answer is B. Now, we will go to the, this question actually appeared in AIEEE 2003. Next question, this says the binding energy per nucleon of deuterium 2H1 and helium nucleus 4He2 is 1.1 MeV and it is 7 MeV respectively. If two deuterium nucleus react to form a single helium nucleus, then the energy releases. So two deuterium react to form one helium nucleus. Then the energy released is, here we have to see the binding energy is given as per nucleon. That means the binding energy of this nucleus, that is helium nucleus, will be 7 into 4 means 28 MeV, and binding energy of deuterium will be, now here actually it is 2 times, so 2 into, that is 1.1 into 2, that means 4 MeV. So this minus this minus this will give you the energy released, that will come as 23.6 MeV, and so answer is our this. So very simple problems if you understand the concept fully. Now next question, that is starting with a sample of pure 66 copper, 7/8 decays into Zn zinc in 15 minutes. The corresponding half-life is. So basically our equation is again n is equal to n0 E minus lambda t. Now n upon n0, here 7/8 of n0 is decays. So what is remaining? 1/8. So this is nothing but here it is 1/8. So 1/8 is equal to E minus lambda 15 minutes. It is lambda into 15. Right? Lambda we know ln 2 upon T half. So here we can put 1/8 E minus ln 2 upon T1 by T1 half into 15. That means if you solve this, then 1/8, if you solve this, then it will come as 1 upon 2 raised to, that is 15 upon T1/2. Here this is nothing but 3 or 15 upon T1/2 is nothing but 3, or T1/2 is 15 upon 3 means it is 5. So our answer is 5 minutes. So let us go to the next question. The binding energy per nucleon of lithium nucleus and helium nucleus 5.6 MeV and 7.06 MeV respectively. Then in the reaction P plus lithium, that is making 2 nucleus of helium, energy of proton must be. So with this, basically what is this energy? 2 into He is given as 7.06. 7.06 this is 2 times, and this is again per nucleon, then how many nucleons are there? That is 4. So this is equal to 8 into 7.06 or 48 into like this. Now what about this lithium? That is, for lithium the energy is given as 5.6 per nucleon. How many nucleons are there? 7. That means this is such an 39.8. Now the energy of proton must be equal to this minus this. This is this minus this means 56.48. 39.80. That means 8. So 14 minus 8. 6. Oh, this is, I think there is some calculation mistake. It's 8. This is okay. This is okay. Here it has gone wrong. It will be 76. This is 39.2. This is 39.20, and this will be 2, and this is 7. That is 17.28 MeV. So this is the answer. Let us go to the next problem. Here it says an alpha particle of 5 MeV energy is scattered through 180 degree by a fixed uranium nucleus. The distance of closest approach is of the order of this thing. So here, here we have been given this energy, and this alpha particle is moving. This alpha particle is moving. It comes to uranium nucleus, and this goes back. 180 degree means this goes back. That means we have to find out the closest approach, how much it will, because they will repel. So this is alpha, this is uranium, and this is their closest approach. Suppose this is R. Then kinetic energy we have been given of alpha particle is 5 MeV. When this will reach to this point, means closest point, the kinetic energy will be converted into potential energy. So this will repel. So this kinetic energy will be converted into potential kinetic energy we have been given, that is 5 MeV. What will be the potential energy? Potential energy will be the potential energy between these two nucleus. That means 1 by 4 pi epsilon 0 into Q1 Q2 upon R. Q1 Q2 upon R we know 1 by 4 pi epsilon 0. Q1 is nothing but 92 E, because atomic number of uranium nucleus is 92. 92 protons will be there, into alpha means 2E upon R. If you solve this with respect to R, okay, let us solve this. 1 by 4 epsilon 0, this will go. This is nothing but 8.99 into 10 raised to 9 into 92 into E is nothing but 1.6 into 10 raised to minus 19 into 2E. We will put E as E only because it will cut into E, and this is mega, and into 10 raised to 6. This E will come. So here this will come as 5.3 into 10 raised to minus 14 meter, or it is 5.3 into 10 raised to minus 12 centimeter, or this is the order of centimeter, 10 raised to minus 12, though the answer will be this. Now we will go to the next question. An alpha nucleus of energy half mv square bombards a heavy nucleus target of charge of JE. Then the distance of closest approach for the alpha nucleus will be proportional to. This question came in AIEEE 2006. So, like in the previous problem, kinetic energy is given as half mv square. Distance of closest approach. Closest approach at that time, KE will be equal to P potential energy, or we can write as half mv square is equal to 1 by 4 pi epsilon 0. This is JE into alpha particle is 2E divided by R. So R is nothing but, if we solve this, then it will come as 4ZE square upon 4 pi epsilon 0 m v square. Now these things are constants, so R is proportional to 1 by m. Your answer is. So now let us go to the next problem. I hope you understand. You are understanding it. In this case, M0 is the mass of the oxygen isotope. MP and Mn are the masses of proton and neutron respectively, the nuclear binding energy. So that means binding energy of delta M C square. So binding energy of basically of this oxygen isotope will be nothing but M0 C square, and binding energy of proton and neutron together, this will have 8 protons, so 8 MP plus how many neutrons? 9 neutrons. So this will come, the binding energy of the isotope is nuclear binding energy of the isotope is basically 8 MP plus 9 Mn minus M0 C square. Basically, it should be minus. Basically, answer should be this with minus sign. So here a little bit error is there. So let us go to the next problem. A nucleus disintegrates into two nuclear parts which have their velocities in the ratio 2:1. The ratio of their nuclear sizes will be this. So a nucleus is there, this disintegrates and their velocities are in the ratio of 2:1. That means V2 is nothing but or you can say, you can write it as V1, V2 is nothing but 2:1. V1 upon V2 is equal to 2/1, or V2 upon V1 is nothing but 1/. Now, here conservation of momentum. M1 V1 will be nothing but m2 v2. The radius of, we know that the radius of this nucleus is where A is the mass number and R0 is the constant. So here R1 upon R2 will be nothing but A1 upon A2 1 by 3. This is the radius. And this is the mass number. This is, we can write as m1 upon m2 . So this will give you m2 v2 upon m2 v1 with this, by putting this m1 in place of m1 we can write m2 v2 upon v1. m2 is already the m2 cuts out. This comes v2 upon v1 1 by 3, and v2 upon v1 is nothing but 1 upon 2 1 upon 3. That means R1 sizes, the ratio of the sizes is you got it? So the answer is the next question. If radius of 23 aluminum 13 nucleus is estimated to be 3.6 Fermi, then the radius of 127 beryllium 52 nucleus will be nearly. This question also appeared in this question. Fermi is a unit to measure the radius. It's a femtometer, you can also say. So R, as in previous problem, R is nothing but A 1 by 3 or R 1 upon R2 is nothing but A1 upon A2 1 by 3. A1 is this, that means mass number is 27, and A2 is nothing but 125, it is basically 125, otherwise problem would come. And this is 1 by 3, and this we can write as 3, 5, 3, 1 by 3, or we can write as 3 upon 5. Now R1 upon R2, that means R2 is nothing but 5 R1 upon 3, 5 into R1 is nothing but 3.6 and 3 Fermi, and this is will come as 6. So this way you can solve this problem. I think these problems should not take 15 to 30 seconds, more than 15 to 30 seconds. Now this question is the rad is correct unit to report the measurement of. What is the rad basically? that you can relate it to radiation. Now, you might have learned our body also absorbs radiation. It's all you know that our body, that's why you are prevented or you are cautioned when you are near to radioactive material. So basically, rad is a unit, old unit, to measure how much radiation you have absorbed. SI unit of this is basically it is gray. We can write it as GY. The conversion is like this: 1 gray is equal to 1 joule per kg, and that is equal to 100 rad. So now this is basically the body absorption of radiation by the body. So this measures the basically biological effect of the radiation, and it is said that a whole body short-term gamma ray dose of 3 gray, that is 300 rad, will cause death in 50% of the population exposed to it. Means 300 rad will cause destruction of 50% of population. So now let us go to our next problem. This problem says the half-life period of a radioactive element X is the same as mean life of a radioactive element Y. Initially they have the same number of atoms. Then basically half-life lambda or you can say T half is nothing but ln 2 divided by lambda x, and mean life of y, that means tau, this is of x and this is of y, equal to 1 by lambda, means it is of y. Now these two things are equal, means ln 2 upon lambda x is equal to 1 by lambda y. This is a disintegration constant. Lambda x is nothing but ln 2 lambda y. This is a positive quantity. That means lambda x is greater than lambda y. Okay. Now lambda is what? Decay constant or disintegration constant. Means lambda is more, means it will decay more. That means X will decay faster than Y. So these were some couple of problems, real-time problems which have appeared in AIEEE. Actually this JEE Mains, which is called today, earlier it was AIEEE, and these questions are from them only from various years. I have consolidated pertaining to nuclear physics. I hope you must have understood these problems, and in the coming videos we will see some more questions, real-time questions from various chapters of physics. So if you like this video, please do subscribe it and do like the video. Thank you very much.